Welcome back to another MLOps.community podcast. This is a coffee session with no coffee. Adam and I are here to talk to Mohamed today about testing-centric development, not test-driven development. Adam, how was it for you, man? We just got done talking to him. I thought it was awesome. I really appreciate his viewpoint. What'd you think?
Yeah, really good. Like I said to him offline, there's lots of stuff about the kind of workflow that I've been thinking about recently, and it's probably actually speaks volumes that even I'd missed some of the real subtle stuff that he's talking about. The holistic view thing was really, really cool. I really like that.
Yeah. So for those of you that do not know who Mohamed is, and it's probably hard to know who Mohamed is if I'm not saying his last name, it's Mohamed Elgendy. Hopefully I'm pronouncing that correctly. I didn't ask him how his name was pronounced, but he is ex-Amazon, ex-Twilio. He's done some really cool stuff. I mean, he gives talks at Amazon's DevCon, Google I/O. He past talks at O'Reilly's AI conference. The guy's pretty notable in the space, and he's also written a book with Manning called Deep Learning for Vision Systems. If you're really enjoying this conversation, then we'll leave a link below for where you can pick up that book. But currently, he went off and he did what most people have been doing recently, is starting their own companies. And he's got this company around testing. And the company is called... wait, let me get this straight. It's Kolena. I was about to say koala, but it is Kolena, and so it's all around testing. And I think this idea of testing, it's not the first time we've talked about it. It is very important, though. We're starting to see it more and more. You're starting to see things like he mentioned in the talk, like the evaluation store. And you're starting to see monitoring companies start to shift and pivot a little bit. I saw just the other day a monitoring company come out with a testing framework, an open source testing framework, because it's almost like it goes hand in hand.
Yeah. And for me, again, coming into the talk, I was very much primed to think of things like, software testing, unit testing, and things like... also data quality reports and the tools out there, but this is different, and the holistic kind of end-to-end view I think is really, really important. The other big takeaway for me is to start thinking about maybe codifying thoughts around failure modes and stuff like that. That was a really cool point, so well worth getting into the talk.
Yeah, and so for me, I think I really enjoyed when you're looking at the documentation that is inherent with testing. Like the more you test, the more that is just a side effect that you have a paper trail, or you have these artifacts which can become documentation in a way. And so how that can help with this, what do they call it? Like the bus problem, that if somebody at your company gets hit by a bus, then all of that information hopefully is not in their head. It is documented somewhere. And also, as I mentioned in the conversation, how that can help for people who are having to jump through the hoops of regulation, as we both know, because you're in the
UK.
The UK, but does it officially fall under the EU regulations? It doesn't anymore, does it?
Not anymore, but we seem to have. Well, I might be wrong, but we seem to have this practice of copying all the EU regulations anyway. So, but that's a sore subject. We don't talk about that.
You do a GitHub pull request, huh? Or you do you do a clone. You do a GitHub clone, and then you take the regulations exactly. So this is our conversation with Mo. And I'm Demetrius Brinkman. I'm here with Adam Sroka, whose name apparently means fried prawn in Swedish, as he told us last time he guest hosted.
That's close. That's really close, yeah.
I knew it was something around there.
That's close.
Anyway, thanks again, Adam, for coming on and joining me for this one. It's always a pleasure to have you. I love the way that you ask questions and your mind thinks. For everyone else out there, I hope you enjoy. All right, guys, we're here. We're ready to talk. I'm super stoked to talk with you, Mo. I know that this has been a long time coming. We chatted, months ago, and we wanted to go over testing, and testing has become something a bit of important topic that
Yeah.
is getting the light that it deserves shown on it. And so today, I want to dive into it with you. I know you're doing cool stuff with your company around testing. And so maybe you can start with what you're doing at your company, and then we'll dive into more testing questions as we go on.
Yeah, absolutely. I think it make sense if I take one step back into why we're doing ML testing. The story will give
Perfect.
um, a lot of context on what we're doing. So my background has been in the ML side before. Now I'm currently the CEO and co-founder of Kolena. This is more of a business side kind of role, but my role has been always on the engineering side. All my career, I've been building and managing ML teams in different environments. And one of the places that we worked for a early stage startup in the CV space, building algorithms to detect threats in X-ray machines. We're selling products to the security and defense space, the DoD, TSA, all the kind of like, and other customers. At this level, we went into there where we're thinking about, okay, let's do build a model, let's say a gun detector, and we say 98% and whatever kind of metric that we're producing, and realize that this doesn't fit the bill for these kind of applications. Similar to a lot of mission critical applications, we can't go and like there's 99% chance that we're going to detect a gun, but 1% chance there's a gun going up there on the plane. So we at this time we started thinking about how the product and the entire goal of the company is affected by the testing problem. So we were pushed by the market and by our customers to think about the testing process and think about our current model training process and how we can stratify our data into real scenarios, real product objective scenarios that we can go to customers and tell them, if it's a gun, we detect a gun in these scenarios with this kind of confidence and other levels and so on, so we can have iterative improvements and so on. So at this point, we did well with that time, and then the company got acquired, and then I was writing my book in computer vision. It's called Deep Learning for Vision Systems. It was published by Manning, and I started thinking about how do we actually solve this pain. I've always been like in that, like a manager of the team or leading the ML teams in my organizations. And then I've always been asked all these hard questions like, hey, Mohamed, why did we fail in this scenario? Or are we ready to deploy? Are we ready for a demo? And we always do our best in the statistical methods that we have today to have some confidence in our products. But in my heart, it's always been, I hope so, right? And I work with my teams. I can't build a systematic process around that. So that was a pain in my career. And we started thinking about, when I was writing the book, I felt like let's dedicate a chapter to research it and write something about this topic. I worked with a few researchers who were working with me on the book, and then we came up with a rigorous systematic ML testing framework. And then we realized that it will never be used. It's just very tedious and time-consuming to be done without proper tooling. So this is what led to our current company now, Kolena. We quit our jobs and we started working on Kolena full-time. So back to your questions, what are we doing here? We're building a machine learning testing and validation platform. And the goal goes beyond the testing. As we realized, as working with our customers and our personal experience, we found out that actually the entire life cycle of the model development revolves around training. But we found that if you shift that into the test-centric development, things get much better. Every upstream process is much more efficient in the terms of data training and the experimentation, and the downstream process in production is like much less production problems. So we realized that the vision here grew from just testing into building a culture of ML quality in the organization. It's not a one-time heroic effort. It's more of a team culture to guarantee that kind of quality level improves by time and being able to measure it and communicate it with everybody.
I think that's really interesting, and it brings me to a point that I think many people might ask you actually if you go through this journey, and you've probably got a good answer for. But you talk about ML testing, and obviously there's a big difference in unit testing, integration testing, all that. But my mind immediately goes to data quality and for tooling.
Absolutely.
So I immediately go to tooling like TDDA, DQ, Great Expectations. So could you elaborate a little bit on why they're different to what you're doing?
Yeah, I mean, we can look at the testing node in the workflow as a node, or we can look at it as a workflow on its own and build the training development on top of it, which is what we did. If you look at testing, let's actually not look at testing, let's look at model quality. Model quality is a function of the model and the test data. And then all our work is focused on the model. This is getting much easier with a lot of tools making the model piece and the training piece much easier. And then the test data is usually an afterthought or less managed. It's basically a benchmark data set that you keep adding to. And then that doesn't end at this. Like if you want to build, like in theory, yes, the testing piece can be a tool or two. But if you want to look at the testing piece as managing the test case manager and then running the inferences, getting reports, comparing models, and you have an eval store that saves all these results, and being able to build analytics and services on top of it and reporting services, it becomes a whole new game. Then we thought about okay, how do we start testing? How do we start solving the testing problem? We thought about, okay, let's build a test case manager. But again, how are you going to deal with the results? And then the test case manager is a whole, like if you're looking at the test data, especially in the vision problem, it's much, much harder. If you want to stratify your data into scenarios, what other option we have now other than labeling it, right? And that is very expensive and time consuming. Now, the reason here is like you have, let's say, hundreds of thousands of images in your benchmark data set. You label them as the way they understand your domain now, and you learn more about your domain. You go ahead and relabel all of this, and it doesn't end. So we realized that we have to fix the problem from here. So we built a test case studio that allows you to stratify and create new scenarios within minutes as opposed to weeks and so on. And then we thought, okay, is this the end of it? No, but we need to manage these test cases and version them and be able to, make sure that, because soon enough when the process is easy, which is what we want, your test data grows from 200 to 1 million to 10 million to 30 million, and your test cases grow from tens to hundreds and thousands. It becomes really hard to manage with our, in a development environment with notebooks and so on. So we found no other way other than building a full platform to manage this whole thing, just to make sure that the end-to-end process finishes in minutes as opposed to weeks if you have to put in different toolings. So I can say, just a short answer to your question, Adam, I can say, yeah, we can put around some toolings and some, Split.io actually does something like this software development side and the testing side. We can put around some toolings, which is what we did into coming into this process. But at the end of the day, if you want to build model development, testing, it has to be a full platform to take the process end to end. Because like you said, Demetrius, before this call, engineers hate to be told, test more. They feel like it's a waste of time, but we had to do it the whole thing to make sure that it's engineers like it.
So if I'm understanding this correctly, it's really trying to take more of a holistic view at testing and
Absolutely.
recognize from a layer above almost that we need to bring testing into every piece of what we're doing.
Absolutely. And on top of that is you can build a process on paper. I worked a lot in change management and process change management, and you can put a process in paper, but having a knowledge base in the organization that builds on top of it is the actual the gold mine here that makes sure that the product improves month after month, year after year. If you have a new engineer joining the team today, they have to ask a lot of questions. Let's, if you're building a car detector, how is our models? What specs are we building against? All these kind of things. Whereas if you go into the platform and just look at the list of test cases and look at the history of test cases. So even when you're looking at, if you're a manager, looking at your team's performance, nothing here about development. You're just looking at the team and your product. So instead of looking at the team as we have a model went from 1991 and so on, we want you to look at, we have features to detect a car at train, and it has improved this way and regressed this way. We have a feature that detects a car with a certain level of occlusion. So, and this way, on top view and side view, so you have all these, the history and the knowledge base that's built here. Within 4 or 5 months, you have a lot of information, a lot of analytics on how to identify failure modes automatically and how to improve the model as the next step. What to do? Is it adding more data, tuning more? All this stuff happens when you have this knowledge base.
Yeah, so let's double click on that for a minute, because I know that we had spoke about the idea of testing as basically bolstering the documentation. And it feels like that's what
Yes,
you're talking about here. It's like
absolutely.
because you have testing and because you're making sure that this knowledge is not siloed in one or two engineers' minds, then you can have something that is more robust and anyone can come in and get up to speed much quicker than if you didn't have this.
Yes.
So, yeah, can you go into that a little bit more? Because I'm not sure I'm fully understanding it.
Yeah, absolutely. So let's go again with a simple example like a car detector. First, you go ahead and you say, I want to build a car detector, and then if you take this case approach, you say, okay, I'm going to break my test data into easy, medium, hard, right? That's a basic thing. And then because I don't know the problem yet, and then you go easy, medium, hard, and then you push to production, you see problems, you come back, and then you say, you know what, I need to look at different kind of evaluation. So I want to see different orientation of the car, different occlusion level, camera conditions, and weather conditions. These are basic, like you can do like 10 to 15 test cases. And then you learn more about, you go ahead, and the more you're working on the improving the product, and then you come back, you see bugs, you start breaking these down into more test cases, more fine-grained, more higher resolution test cases. Now, that's a year in. You start with 3, ends up being 10, 20, hundreds of those. And then an engineer joins in a year. Now, they have been working on car detectors. They understand exactly what we're looking for. We always, as data scientists, we look at the end when you evaluate the model, or when you're training, you look at the data one by one. You don't have a sense of what this is. Like you look at a car, you don't know what you're looking at. It's a car. You don't know. It's like you care about occlusion, you care about weather conditions, and so on. And then the deployment environment is different for each customer. If it's like a robotics kind of application indoors, you don't need some kind of like weather conditions, for example. Others, you need others. So to understand the product specifications, understand the deployment environment, the customer environment, understand what the team has been working on, it all happens in that knowledge base. Knowledge base starts from just looking at the list of test cases and looking at the history of how things happened, and being able to understand within the first couple of weeks, these are the customers that I'm building for, and these are the specs that we care about.
So that one thing that comes to mind when you're talking about like tens and hundreds of test cases and things like that, and I can see the value in it, but do you or have you experienced any issues with actually the computational cost of running so many tests and things like that, and like building all the cost of building data sets for the purposes of testing and things like that? Because I can imagine that you're adding loads of robustness and scalability, right? But at
Yeah.
quite a significant computational cost, I guess.
No, absolutely. And actually, we are pushing for more testing, and we're pushing for much, much larger test data, which could be intuitively increase the computation cost and storage and effort and so on. The way we solve this problem is this eval store. I know you guys talked several times in your podcast about eval store, and we're fans of the concept. When you're testing on, let's say, hundreds of thousands of images, and you run a model, and then you have 50,000 more images, and then the positive thing about having a platform to do that is you need to run less inferences because the model has been tested on the other image before. So you look at the nucleus item in this process is the image or an object, whether it's a video frame or something. So you look at the image, and we create a history of this image. So at the end of the day, when you look at an image, you see that this image has been tested on these 10 models, and the history has performance and so on. So now that when you're testing and you're retesting again, if this version of the model has been tested on this version of the image or the data sample, if it's different than if it's an NLP or audio side, then you test less. So you are testing more, but you are running much, much less computation. And comes here the reporting piece. Most of the testing happens not because the engineers are validating their product, it's answering questions and being able to compare models. That happens once. Right. So we saw
Okay.
this is actually very practical. Team spends like if you're running emphasis on millions of images, you get like spend a couple hours on that, and then it's up there. And then every time you add more data, you run anything on the model, it just runs the addition data of this. So we saw the 5x of the 10x even of like our current customers, 10x the size of the data, and the number of test runs that they're running with much lower computation cost
Wow.
than before.
And so you talk
because
about
this goes back to the exact question, Adam, you were asking, or of whether it's a tool or a platform, because testing is not liked and it's always an afterthought. And to tell people you got to do testing, we found that we have to solve the whole thing. We cannot solve one piece at a time.
let's riff off of that really fast because I think it's a theme and everyone knows it, that testing is not liked and nobody wants to hear that they need to do more tests. Do you have silver bullets for someone? Like, let's say Adam goes tomorrow and he says, listen, everybody on his team, we got to test. Like, I just had this podcast yesterday with Mo and I realized that we're not testing enough. What do you do to get buy-in? How do you convince people to go along this journey with you?
Yeah, we've been, so I've been doing this myself in my career, and then I'm doing it every day today, right? given I'm one of the product. We see now that most of quality initiatives start from a person in the team, a technical leader, a manager, that is pushing this quality levels. That's number one. Or they're getting a lot of pain from production, from customers, and then customers are pressing on business, and business is pressing on engineering. So when we try to look at the team, these are the two main things we focus on. I tell engineers or data scientists, hey, you actually have a slide on this specifically. That's the first slide we talk about all the time. Is if you test more or test right, if you have a systematic test process, you will train less, you will do less data collection and data labeling, you will have to answer a lot less questions from people because the answers are already there. Data scientists usually they are skeptical or engineers skeptical until they see the end to end of how we built it, and they start seeing, okay, we see your point, and then we do like a pilot or something. They see the numbers before, like how many times they tested. Let's say before it was once a week, now 10 times a week, but the actual hours of testing are much less because they just like it. They run a lot of tests, and the actual hours of spent on the training, which is a very painful process, shooting in the dark kind of process. All this get less. So my pitch to data scientists is like, hey, you don't have to spend all this time. You'll spend less time on testing as well, and you will have a systematic process that everybody will agree on, product as well, product teams and business teams.
So I can certainly get that. Yeah, I can see that. Actually, the point about being a platform and how you then save on more runs and you save time holistically makes a lot of sense. Actually, one thing so the next thing, because my brain's whirring, right? But the next thing that springs to mind then is so someone like me that came into data science from a physics background, getting started with testing, I've got all these software engineers in my ears, like a young data scientist, getting started, it can seem quite alien and quite like, I don't really get it, TDD, how do I do that? And actually, as you go further in your career, many people never get over that hurdle of they just don't get it or they don't do it right. And I've seen so many teams where we don't do any testing. Oh, fine, okay. So, because I'm aware that like your testing is only as good as your quality. It's a bit of a skill. Like testing is a bit of a skill. So, do you have any recommended resources or like routes for people to get confident with this or get good at testing? And like, how should they be? What approaches should we be taking? Like, does TDD work and stuff like that? I'd love to hear your thoughts.
Absolutely. Starting note is we try to avoid the word TDD, having been very controversial. It is TDD though. I mean, it is what it is. We call it test-centric development, and the reason TDD is a little bit controversial in the software side because it's more of a deterministic. It's not a statistical process. It's basically compared to ML, it's really hard to infer performance based on data sets or benchmarks. If you're looking at human level performance, if you give a human set of data and they are accurate in 99% of the data, you can infer that this 1% is the most adversarial case for a human level. But you cannot do the same thing for a data product like ML. You have to actually include every piece of it. So, I'm sorry, I forgot your question.
Yeah, and so that's interesting in itself that TDD kind of, because I've heard loads of mixed views on that. So the next part for me was,
yes, the TDD,
how do I get good at testing, and how do I, as like from a machine learning point of view, what are the books, the skills, things?
Yeah, so for that, the testing is basically done now by every data scientist, or the mechanics of it, which is running inferences and getting results. So that is not changed. And what we are changing is the way you're managing your data, your test data. Two things. Test data has to cover the entire span of what you're trying to achieve. Sounds impossible, but it's actually much, much more manageable than trying to do that on the training data. Test data, if you're trying to you're building product from specs, you say I want to be able to detect this class with these kind of specs. You go backwards and you create that, play with your data, create these test cases. Now these test cases are the way they are created today, whether they're images or text, they require a lot of data wrangling. We built a studio for that. That it's a UI that you're able to stratify your data, search your data based on any scenario that you're looking for without prior labeling. So this is a whole UI thing. And then you're able to add some augmentations to test robustness and include some objects. So we created like an interesting, intuitive studio that we looked a lot about the UX piece of it, how to make these engineers or data scientists coming from non-engineering background, but they understand data. They understand what to look for in data. They understand what neural networks are. And then we start building UI on top of this. And then we also built an SDK to make it, Python SDK to make it so easy for them to integrate, similar to weights and biases, to integrate into their current workflows. So the UX piece is the biggest piece into making sure that there's adoption into this new workflow. Because we're building, at the end of the day, building an ML testing tool, we're starting a new category of toolings. We're not telling people, hey, you've done, and we found that we're changing the behavior. And I believe that the workflow will change after, if that test-centric approach is created, the way you're managing your test data will reflect into the way you're managing your training data, you reflect in everything upstream. So data scientists are already familiar with the pieces that we're working with, and we cut off all the data wrangling approach that they have to, like, process and understand and even like the manual approach of having to look at the data one by one, labeling this approach. We cut all these hurdles because we were thinking a lot when we were working on testing about the statement that we started with. Nobody wants to be told test a lot, right? So we tried to make sure that this is easy, and everything we're measuring, we're testing how long it's taking you and how easy it is compared to current approaches.
And so there's one side effect that I think we haven't touched on, but it kind of gets me excited about the way that you're looking at the problem. And that is considering right now, both Adam and I are in the EU, and there are proposed regulations that are coming out for machine learning and AI, as they like to call it, in the EU. And so I feel like have you thought about like how this and how the idea of testing / creating more of a knowledge hub and better documentation can play into the regulation aspect?
Yeah, actually, not just we have thought about it. At the stealth mode that we are at now at Kolena, we are working with specific teams that are facing regulations and independent regulators and independent auditors into their process. So we start with, if you look at any domain, now it's getting highly regulated, and then they are telling you, let's say if you're working on a face detection problem, you have to show gender bias, race bias, age bias, all these kind of metrics that you can just say like 90-something% in detecting faces. So, and the same thing for safety applications and mobility applications in AV and so on. Now, this all starts from the way the regulators, and we work heavily with these regulators, the way and the great example of this is nest.gov. If you guys are familiar with the It's a U.S. Nonprofit organization. So basically, they are the way if you look at the reports, it's an open source. You look at the reports, they care a lot about these what we call specs. Again, I look at regulation requirements, as specs, and then you look at these regulations. They want test biometric differences or any other like they care about, and then you start implementing that in your specs. You create test cases, test your model, identify failure modes, and then train against only these specs. So we're trying to eliminate the shooting in the dark kind of process in the training. So it starts from there. Like these regulations are requirements. And then easily after that, if you're done this, it's so easy to create specific reports for them. Based on you have already the results, you create specific reports and custom reports for these organizations. It's a common problem, the regulations thing. Like we're starting with actually areas that are heavily regulated because the need here, they're looking at testing to be able to answer these questions.
There's that pain that you were talking about earlier and how you see the different, it being reflected in the business. So I want to change gears a little bit. Well, I mean, it's not completely off topic, but one thing that testing does, and we spoke about before, is identifying failure modes. And so I wanted to dive a little bit deeper into that. And how does testing identify these failure modes and get this granular understanding of the model behavior for each scenario?
Actually, that's the core of what everything we're promising is at this point. Do you mind if I share some slides? I put a couple slides to answer, like to give a background of what failure modes are.
Yeah, throw it for sure.
So yeah, this is actually like we start with this, and that's a failure mode. Like it's from our previous example, like I shared, we were building a gun detector, and we spent months improving the statistical evaluation metrics that we have, and then we came up with like a model of 99% accurate on like our F1 score, and then we did not find like we put it in a demo, and that gun was that clear, and then we missed it in a very easy case. And that is a failure mode that was hidden. We did not understand that this was a failure mode. We just assumed that 91% that's missing is probably the most adversarial case, and we didn't notice that. And then the problem here happens, again, goes to the failure modes. We're not able to identify failure modes as long as we're using the current evaluation processes, which basically, if you look at it today, we have some benchmark data sets. We keep making it larger and increasing into it. We run inferences, and we spend days or even weeks in some applications trying to staring at error graphs and evaluating the model. So yeah, currently at the current evaluation process, we run inferences on large arbitrarily created benchmark sets, and then we spend days or even weeks staring at error charts, try to understand the model performance, and then that involves a lot of images or data samples to look at the failures. If you have 1 million images in your test set and you fail 1%, that's 10,000 images, right? So you can understand everything and write down notes and so on, create reports, and then at the end you just produce some magical global metric, right? And then doesn't tell you exactly what's happening. So this is the world that we live in today. And best case scenario in teams that want to evolve in the quality side, they just document this somewhere and then try to manage that somewhere. And then you see here two main problems: these frozen benchmarks and the global metric. And this takes us to that problem, the hidden certification problem, which goes directly to your point about failure modes. So these classes, these global metrics for the class, they don't, like we said, we don't capture the full picture. And then the hidden certification problem just basically says that these models, they exhibit highly variable performance for different subclasses within the class. And then the authors of the hidden certification paper just shared another example from a different domain, which is X-ray, just X-ray images. They have been measuring this blue curve, AUC curve, which is the aggregate or the global metric, only to find out that the slice that they care about, is that green slice, which is no chest, doesn't involve chest traits. So that was failing silently, and the same gun examples, and that this applies to every domain in the ML side. So to your question, Demetrius, the problem in identifying failure modes happens in the way you are managing your data. We want to take a test case approach in managing the data. So I'm going to skip this, but this is basically what we're pushing for. We are pushing for a paradigm shift that from a world that we live in today that involves a lot of large benchmarks, arbitrarily split data, into more of fine-grained, well-curated test cases. So in the gun example here, instead of throwing a lot of gun examples there, just stratify those in like 6 or 7 as a start. You go here, like say, hey, I'm building this product. I want to be able to identify a gun in empty bin, like what we had, and different views. And you add to that different camera conditions and sensors, because that affects heavily the neural network performance. And then you have what we like to say, like high resolution test results. And then you're able to compare models and different runs based on these criteria that you care about. So if we're looking at this global metric, we had a model that had 96.8% that improved to 99. We deployed the 99 because that's all we know. But if you look here, we found out that we made a push when we were going from A to B to improve on the occlusion side. And we have regressed in an easy case, silently again. So that is what I meant by failure mode. Defining pass or fail criteria, we thought it's a hard thing to do. It's not that hard. It can be done. And that is the only gate to a fully automated workflow. We never deploy without, go ahead.
For just heads up for the people that are only listening, we've got two different columns here, and you see model A, which is actually a lower accuracy, but it ticks the boxes more than model B, which has this 99% accuracy, but it's actually failing quite significantly on more of these boxes, like the gun in the empty bin or in the different
like
sections
different views,
that you're testing for, right? Yeah.
Absolutely.
So,
yeah. And then with this, if you look at that approach, let's talk again about why this makes everything above in the upstream process less of it, less training, less and so on. Now, at the simplest form of it, if you have a fleet of models, which we always have, we have tons of models that we're sending, and then don't just have them sit on their AWS bucket or GCP bucket. Now they just run inferences and store them on Kolena. And now you have a new scenario. You have a new customer that's saying this, and they care about their environment has these types of sensors and these types of scenarios. Then you run all your models on this scenario, and then find the best to deploy. So in many cases, we've seen that you don't even need to train a new model. The idea of having one general model that is great at everything is really painful. And then you find yourself playing like a whack-a-mole, like you crush a bug and then you go ahead and a pop comes up. So what we ended up doing is we said, okay, this model is great for demo. Demo is a controlled environment. Let's give customers great demos first. And now another scenario is, okay, these types of X-ray machines or this model of this kind of sensors have this environment. You don't have to build a model that is great for all sensors or great for all scenarios. Have a few models, and then on top of that, you can even end up having an ensemble of models that are great at different things. So the mindset of building an ML product completely changes from the mindset of what we have today. Is like, let's put more data, let's make this model brilliant at every aspect of development. And then I want to show like this last thing here that is what the workflow looks like. We're looking at, this is what we call the test-centric development for production ML. We start with the product specs. It has to be, what are you building for? Let's write the product specs and create these test cases. And then when you create test cases, test them. And then you start here improving on it, like assemble training data and train and test, assemble training data and train and test. So it's all, like this is the target, like you define the target before you take a swing, right? So we set the target right here. And you keep taking swings until you're ready. And then when you observe a bug in production, go back to your tests. Create the test case, like this bug again, like the gun scenario that we saw. Create a test case, test your models, and then assemble. Because the solution, what we end up doing today is, we have a problem, let's create more training data. And then to test whether the model is good at a scenario, you need probably tens of hundreds of images, but to train a model in a scenario, you need much, much larger data. So, and then the solution is not always, let's get more data. It could be tuning, could be augmentation, it could be different things. So training, the collecting data and labeling is a very expensive piece, very painful, and it's always solved at the labeling piece and automating the labeling piece. I believe that it can be heavily reduced by working backwards from the goal and going through the development life cycle.
So I find that really interesting. And again, I'll just, for people that are just listening to this, so presented here is like an ML production sort of development workflow that steps through getting the business objective and the specs through to then creating some tests and then, yeah, testing your model performance and shipping it and so on and so on. But it has two like feedback loops. One is the one you would typically see in these kind of diagrams of get your training data, train some models, test the performance, and feed that back until you hit a sort of threshold. And then, but the other loop that's probably unique to this diagram from my perspective anyways, the sort of once you've deployed a model to production, perhaps you look out for bugs to identify and then go back to create tests to catch them and so on and so forth, which I think is a really interesting way to do this. But that one thing I wanted to ask, and it kind of inspired by the diagram with the test cases, was so this, I can see this working. It's kind of after the fact a little bit though. Is there a way to identify scenario? I think I know the answer to this, but I guess the only way to identify scenarios is through some really vigorous brainstorming, like up front, or through experience and domain knowledge and expertise. There's not another way of doing that that's quite natural, is there?
That's exactly what it is, and this is where the knowledge base comes in handy. You have to go through this. It's either personal experience, or like for the product manager or the team, data science team, or it comes from iterating over the product. Either way, after some time, you are learning more about your domain. Even if you're working the same domain, but different types of customers, it's completely like you want to understand exactly what you're testing for. So we believe that everything starts here, either the product specs or the test cases. Test cases is like when I have a new data scientist joining the team, first thing is like, look at the test cases that we have and look at the history of models, how we improved. Like we've always been good at these scenarios. We care less about, and we've always been bad. And then you start managing, the whole biggest problem I hear about ML is how do you product manage it? How do you always ask the ML team and they tell you it's an iterative process, maybe in some time, which the rightfully so, like it's a painful process, but we want to make sure that it's like a software, it's an engineering product, it can be product managed. You can say, we see our customers saying that, okay, in our OKRs next quarter, we need to improve on these 5 scenarios, make sure and not regress in what we have. And then you're actually incrementally, systematically improving. And every time is actually leading to real improvement towards the target, which is that product or that customer.
I really love that as well, because it again puts the end user right at the very core of what people perceive as to be a very techie process, but actually like that feedback from the expert, the end user and such becomes even more important.
In addition to puts the customer, the end user, puts the product and business team heavily involved in the process. This is where we had to, back to that, the point is like it can't be just a dev tool. If you want to build an ML testing, we believe that everything starts from testing. So you have to build a UI and some executive dashboard and manager dashboard to manage even the team's performance. Like this is like a version of DevTool plus Jira kind of thing, to be able to manage these test cases and all the kind of stuff that we jump through tools as data scientists all the time. And to go to teams and tell them, change what you're doing, we have to make sure that tell them, hey, everything in there is much easier than having to jump through different tools.
It's so cool. I love seeing this. And so there is one thing I think we should probably highlight too. You've been talking a lot about computer vision examples. How does this differ when it's on structured data and unstructured data? Like what are the big things that you see?
Actually, it gets easier. Let me turn my screen off. So it gets a little bit easier in text data, table data, not audio, but the hardest piece why what we're talking about is not implemented. We talked to hundreds of people, of teams, especially last year and before that. The biggest piece is like, how do you make this paradigm shift from these data sets into scenarios? Because you can collect for these scenarios, but usually this is not the starting point. Like you're starting today when we have millions of images in the test set. How do I stratify that? Now, what our solution for this, we built an image retrieval system, or we like to look at it as more of a recommender plus image retriever system, that you're able to search for scenarios. Like if the three of us are looking like we're here like searching image trace data. Like an adult with a beard, probably the three of us will come up, and then adult in a beard and headphones, only I will come up, right? So basically, you're able now to search your data for the exact scenarios you're looking for, and then there's another piece of in that studio, test case studio. We had a whole piece, like 40% of our product is that test case studio. It's think of it as a creative space. You go in there and then play with the images, stratify, augment, add any kind of more scenarios, and then create a test case within minutes. Now that is much easier in text. Searching text is much easier. Augmented text is much easier. So creating these and even lower computational cost as well. So we started with vision because we believe that this is the hardest problem. We are spent most of our careers in this area. We actually are building our NLP product. Will be out by March. And we're seeing it's the test case manager is the same, being able to manage and version test cases and add more and edit and so on. But being able to, the studio is much easier than going with images. So the structured data like tables and text data is easier to go through stratifying piece.
Sweet. I can't let you leave here without you talking about your book, because I think that's how I first started like following you and I found out about you. Can we go into that a little bit and just tell us, like, so the book is, for anybody that doesn't know, it's Machine Learning for Vision Systems. What can we expect there besides what is on the tin?
Yeah. So the book is called Deep Learning for Vision Systems, and it starts after you have understood what the machine learning workflow looks like. And the story of this happened again, a few steps before. I was at Amazon and I was at the Kindle organization. I wanted to work on the ML side. I found a gap in the CV gap inside there. That was back 2014, 2015. I found a gap here in having like a CV authority in the organization. So I founded an organization, CV think tank for different teams in Amazon. To start with that, to start building a team, it's how hard it is to hire ML engineers. It was much harder back then. So my approach was, okay, Amazon has a organization called MLU, Machine Learning University, and it's for Amazon engineers. So I kicked off a course in the CV side, and we had 30 engineers in the room, and then we started with 5 of those after a couple months, and that was the seed of the team. So the project initially started as that, and then from creating a lot of material and I worked with Udacity in creating ML nanodegree and Intel in different organizations. So from creating a lot of content, I realized that they have it's all told from one angle, which is same workflow, the train, test, and deploy. But there's a lot of, and then some are heavy on math, some are heavy on applications. And my belief is you need a little bit of math just to understand what's going on. So I don't want to omit it, but you don't need to take a calculus course or some kind of course. It always starts with calculus 101 or linear algebra 101. So I inserted this math. It's a very practical book, and I wanted people to understand these math pieces for one goal, to be able to read and implement research papers. So all books are going through explaining concepts. I was trying to train the readers to learn on their own. So I have a full chapter after I explain these fundamentals. I have a full chapter just going through maybe 7 or 8 papers, one by one, and dissecting them and creating the code for them. Just to, after that, because you understand that ML is just evolving heavily, the books get obsolete in a couple of years. And the goal here is not really to share information. It's more to teach engineers how to go ahead and learn on their own, read papers, and stay up to date with the current information. So hopefully, to answer your question, Demetrius, hopefully after reading the book, you'll or others be able to go ahead and read any paper as much as I can, and then being able to implement it, understand what they're talking about, and implement it in code.
That's so cool. So we'll leave a link to the book if anyone wants to get their hands on it. And Mo, this has been amazing. I love talking to you about this awesome new paradigm the new idea of, as you do not like to call it TDD, that is a bad word in your, it's a
We're doing
four-letter word, I guess.
Test-centric development now.
Yes, test-centric development. It's so cool to hear about all these different ways that people are attacking the problems and how we're trying to evolve the space that we're in right now. It's obvious that there is a lot of pain in the space, and it's obvious that a lot of maturing needs to happen. So that's why I wanted to get you on here and talk to you about how you see this maturing and evolution happening over the next 2 to 5 years. And it's been great. You definitely ticked the box on that one. I appreciate it. And Adam, thank you for coming, man. As always, it's a pleasure having you here, co-hosting with you.
No, thanks very much. And I've kind of just written a load of stuff about deploying ML engineering guidelines, and I have to rip some of that up, I think, and revisit some of this testing stuff.
Oh, that's how you know it's good, man. That's how you know it's real good. So he made you think about it again. Sweet. Mohamed, I appreciate it, man. We're going to end it here.
Thanks, Demetrius and Adam. Thank you guys for having me. It was a great conversation.
Cheers.